Hello and welcome to the webinar. The title today is Cybersecurity, Trust No One, Securing Third-Party Connections to Industrial Control Systems. Little housekeeping before we begin. Thank you all for joining us. I want to make sure that everyone can hear me properly. The webinar has officially started. If you cannot hear me speaking, please check to make sure your computer mute button is turned to off. Please, you can log off and log back in if you're having a problem. And if you still cannot hear me, please click the Q&A box on your screen to contact tech support, and an engineer will assist you. Some functionality of the portal here. There's a chat box that enables us all to have a side conversation if we'd like during the presentation. And if you'd like to ask a question of our expert presenter today, please use that button with the question mark. That enables you to submit a question to us, and I will present that to Scott. Good afternoon. My name is Chris McNamara. I am Director of Content with Smart Industry. Today I'm serving as a contributing moderator with Control Global. And our expert speaker is Scott Coleman. Scott is the Director of Marketing and Product Management with OWL Cyber Defense. Hello, Scott.
Good morning, or good afternoon, I guess, depending on where you are.
I think we are good to go. I'll pass the controls over to you, Scott, and you can take it away.
All right. Thanks, Chris. So, good day, everybody. Today we're going to be talking about third-party isolated controls and securing the industrial control system networks and thinking about those third parties that connect to the networks. Most of them have legitimate reasons. And then we're going to look at how the DHS recommends defending against unwanted intrusions that may be created in supporting those third parties that need to access your networks. So we'll move right into it. So if you think about control systems and how they were deployed in the past, you had plants that were very isolated, both from a physical perspective and from a networking perspective. And the things that were important were safety, reliability, and system resiliency. As we move forward with the digital world, right, we have a lot more connectivity there, providing expert information both to those working inside the facility and outside the facility. The problem with that is that we're focused on automation and efficiency and remote management, but each of those connections really becomes a potential threat. And so the Department of Homeland Security has come out with some recommendations saying how do we reduce those threats, how do we protect ourselves, and what do we look at to do that. So if you look at your facility and you think about those entities, those parties that need access. So you've got potentially maybe you're pushing something out to the cloud. You've got suppliers providing equipment, updates. You have software vendors sending in patches that may need to be implemented. Maybe you've got contractors or third parties, disaster recovery solution, just general logistics for plant operations. You want to do some remote monitoring, and you've got third parties that have service level agreements that need to be met in order to maintain the equipment that's operating inside the plant. So these are all legitimate reasons and entities that need connectivity. The problem is each of those connections there could potentially become a cyber threat against the network. You see the quote there from the U.S. Department of Energy. So with trusted networks, remote access, mobile devices, vendors, and supply chains become the most likely route of attack, basically. And what they're saying is, and similar to what happened at Sony, what happened at Target, is it's those third parties that you're not thinking about as a potential cyber threat or attack vector, which may become that vulnerability you need to be aware of. So clearly there's a lot of different kinds of companies and applications that are used today to get information in and out of the network. You've got different applications with different functions, doing different things. You have historians and other types of applications that need to get information in and out. And then you've got standard things like OPC and Modbus and those kinds of applications. Again, In order to improve the functionality, operational aspects of the plant or the facility, you need connectivity and you need information to be shared from the facility out to those surrounding third parties. So what can we do? What do we want to do to mitigate those threats? So we need to enable those data flows. The data still needs to get out to those third parties to meet your SLAs or whatever else you have in place with those entities. But nevertheless, we want to be secure. You want that plant or that facility to be secure, so what do we need to do? So if we turn to the Department of Homeland Security, they've actually issued a white paper stating 7 strategies for defending industrial control systems. And if we look at a couple of those, we just pull out 3 or 4 of those and look at those a little deeper. One of the first things they recommend is reducing or eliminating the number of connections in and out of the network. So just by reducing unneeded connections, you're going to reduce your potential threat vectors into the network. Secondly, you want to convert two-way connections to one-way connections out of the plant. So how do you get data to those folks outside of your plant? Convert two-way connections that are coming into your plant to a one-way connection. And then for those remaining connections that have to be two-way that maybe you can't convert to a one-way, how do you secure those and what do you do? So we're going to go through each of those and look at them a little bit deeper in terms of what's happening. As you think about the different types of connectivity and entities you're connecting, if you think about the Internet of Things, if you think about the industrial Internet of Things, and you think about IT and OT convergence, all those things are building and creating lots and lots of connection points, lots of sensor data, information that needs to be monitored. But each of those is making a hole in your network. Right? Each of those has penetrated your perimeter defense and has created a potential threat vector. And you think about people talking about firewalls and pinholes, right? Well, for data, they don't really care how big that pinhole is or isn't, is a way in. So pinholes really don't protect your network. So let's look at ways to eliminate as many of those pinholes as possible and while still being able to share the data that's necessary to run your plant and your operations. Okay, so did you start out, first step is, well, what do I actually have out there? Who am I connected to? What are the reasons for connecting to me? What kind of information do they need to do their jobs? And what do I need to share with them? So you sort of do that audit. You map your networks, you find those external connection points, and you determine who has access to what, and then determine what's necessary. So once you've done that assessment, you see your network gets a lot cleaner. You remove those extraneous connections that don't need to be there, and now you've got a much cleaner looking environment. And now you think about, how do I consolidate anything that was redundant? Did I make sure I removed all the unneeded stuff? Anything that's unauthorized, of course you want to remove. And then establishing least privilege account access. So that people are only accessing things that they need to, only getting to those segments of your network, the portions of your network that are necessary for them to do what they do, and not extend it into other things. So next step, and what you would have is a cleaner network. So we've got is the remaining legitimate connections at this point. Now, the problem is we still got two-way connections, right? So each of these guys, because that's the way the world operates today. Everyone thinks about two-way connections. I send you data. Did you get my data? Great, thank you very much. I'm going to send you some more data. Did you get my data? And that kind of thing. We'll think a little bit later about what we do in terms of moving to one-way connections and how that works. But at this point, you've cleaned up your network, but you still got a lot of two-way connections. So we still got a lot of vulnerabilities there that we need to address.
Hey, Scott.
So the first step, yes.
This is Chris. Let me jump in here. We have a question from Charles Huffman. He asks, how are you defining a pinhole? Protocol and a port?
So yes, sort of all of the above. It basically, if you think about a firewall and what it does, it's allowing routable traffic from the outside through to the inside. And as we move to a one-way connection, we'll be looking at completely closing that pinhole, and basically no traffic whatsoever will be moving through those pinholes. So I'm using it a little liberally in terms of any basically opening or connection in through an external perimeter into something internal that you want protected.
Great, thanks.
Sure. So the next step, or the first step, that we've done our audit, we've gotten rid of stuff that we don't need, and now we're going to start to convert convert the two-way connections that we have remaining to one-way connections. And we think about how many of those connections can we make as a one-way out push. So maybe someone has to come in and find out how long a system has been in operation, how many hours of service has it been operating, what is the flow rate of something. So all legitimate pieces of information, but instead of having you reach into my network that I want to secure and protect, why don't I just push that data to you? You describe to me what you need in terms of data to do the functionality and perform the operation that you need to, and I'm going to push that data to you. I'm going to create a one-way path out, and I'm going to push that data to you. You get what you need to do your job, and now I've eliminated one of those threat vectors into my network. So if we go back to our circle, oops, too far. So we go back to our circle. So some of those blue two-way connections have now been turned into green one-way connections. So I've identified all those places where, oh wait, someone's just doing remote monitoring, right? They just need syslog information from me or SIM data from me that describes what's happening to the equipment or the system inside the plant, and so they keep tabs on what's happening, but they're doing remote monitoring. We sort of call that remote monitoring without remote access. There's a lot of different tool sets that you can get. Dream Report comes to mind, where they have these nice dashboards that shows what's happening inside the plant, and they need data, obviously, to populate those dashboards. But as you're doing that, how do I get that data out to an application like that? So we've tested the solutions with that, and you just push that data out, and you don't request it. So that's really the concept here is I'll push the data to you, you populate your solution, and now you're reflecting what's happening operationally inside the plant. So remote access, or remote monitoring, without remote access. And then, of course, same kinds of information. There's many sort of third parties that provide, so the OEMs providing equipment for inside the plants, but they need to know what's going on, and we do the same thing in those environments where we provide information pushing out. So what we see here is some of those two-way connections have been converted to one-way pushes of data, and I've reduced my threat vector, my footprint against which someone could mount an attack against me. So now if we look at the two-way connections into the network. So maybe I've got some software. I need to do a patch on one of my machines and get it up to date. So again, the DHS recommends you should make that a one-way only transaction. So you validate, verify, or authenticate that software that needs to be pushed into the plant. Once you've validated it with a hash sum, something along those lines, then you go ahead and authorize it and push that file in or that update in. You verify that it's authentic, it's from the originator, and then you push it in. And that's the only thing it does. There's no two-way communication. Again, you're preventing that connection from becoming a threat vector and allowing someone to leverage it and attack the network. So if we look back to our network here of entities, third parties that are connecting, we've now gotten rid of the two-way ins, and that's now a one-way in, and that leaves us with one of the blue lines that's still a two-way. So in this case, that's one we can't get rid of, right? So what the DHS says here is, hey, if I've got a two-way connection that I absolutely have to have, and we all know those exist. It's probably the only use case where you don't have that is like nuclear power plants where they've completely isolated and they're truly one-way out only. But I do have a remaining two-way connection that I'd like to use and you need to use. The recommendation is to lock that down, close any unused ports, limit the command and control connections, what's actually going to occur on there, and then now you've got your intrusion detection systems, you've got all the other threat mitigation, threat analysis, that those resources that you can now apply to this connection. And let's be realistic, and maybe there's 3 or 4 of these. But instead of having 5, 10, 15, 25 connections all in that I've got to monitor and do my intrusion detection and all those other levels of security against. Now I've converted the one-way outs to one-ways in, and now I've got a much smaller group of two-way connections that I can put resources, apply resources to make sure that those threats are mitigated, and I'm watching very strictly against what's happening there. So if we go back to our circle, right, at this point, I've basically modified all of my connections to either be one-way out, one-way in, or a single connection, heavily managed and monitored, so that my remaining two-way connections are A, fewer in number, and B, I can put a lot of resources against us to make sure that they're doing what I need to, and people aren't using those in ways that are inappropriate. So we talked about doing one-way out and one-way in, and then reducing that two-way traffic, and how do you do that? So the approach that is supported and recommended by the Department of Homeland Security is a data diode. So some of you may or may not be familiar with data diodes and what they do. A data diode is based on hardware. So if you think about other security measures, most of them, all of them are software-based. So they have got some kind of configuration that is restricting flows or trying to restrict access. The basis for a data diode is that it's hardware secured. So what that prevents is vulnerabilities that are due to malware. There's limited management because once you've configured it to operate, you don't need to be updating it with signatures and modifications and those kind of things. So it kind of sounds audacious to say that it's unhackable, but you end up with a solution because of the physics, because of the hardware underlying how a diode works. You can't actually modify it. You cannot get around the physical layer security that's inherent in a data diode. Attacks that are against software-based solutions either take advantage of some kind of vulnerability that's in there, stolen credentials, malware there, and there's management that has to be occur on a regular basis to keep them up to date and keep them secure. So I'm just going to walk through real quick here what a diode is, how it works, and how it can work in a two-way environment. So if you think of a one-way data valve, where data can only move in one direction, that's really what a data diode. Water can only go through a valve in one direction, and you've got data that can only move through a data diode in one direction. It can scale up. It's used to segment and protect sensitive networks. Anything behind it can't be reached. And you've got a physical layer there that's enabling a hardware-enforced one-way only transfer. How this works in the two-way world is one of those questions that we get all the time. People say, okay, I get that it's one way. I get that the inherent security of a diode, the physical nature of it prevents people from getting in. But how does that work in a way where all my networks are two ways? With the exception of some things like syslog where it's a UDP push, that's clearly a use case where it's obvious how that would work. But if I have a TCP/IP connection, how is that going to work across the diode? So to explain that, what we have is a proxy on either side. So I have the source side, and so this is the side where the information that is important to me or I need to share is generated. So whether that's, again, it could be a syslog information, it could be historian data, it could be the output of a particular, of a turbine or whatever it is, that information is being sent to the destination today. What occurs is the source side of the data diode has a proxy, and it terminates the TCP/IP session. Now, it could also, terminate a Modbus session. It could terminate an OPC session. It could, terminate a Pi historian replication session. Whatever it is, either at the transport layer or at the application layer, it'll terminate that session. So the data is sent to the diode. The diode becomes the new endpoint. So previously, A was talking to B, or source was talking to destination. The source side of the diode becomes the new, B prime, if you will, so A talking to B prime instead of the original B. The session is terminated, so all TCP/IP, the acknowledgments, the ACKs and NACKs, and all those things that are expected of the protocol are all followed and executed. What happens is we then strip out the actual payload, because at the end of the day, it's the data, it's the payload that's important to the end user at the other side. Pull that payload out. We actually use ATM, if you're familiar with the protocol, asynchronous transfer mode, that was really developed by the phone companies for high bandwidth voice and data. We use ATM across the platform. The payload is stuck into an ATM cell, transported across. We're talking, inches. And then on the other side, so none of the IP address information, none of the MAC information, so none of the routing information ever traverses the data diode, gets to the other side. At that point, there is basically a table that says any incoming traffic on ATM, channel XYZ is actually mapped to destination B. And it was, by the way, this is a TCP/IP session, so therefore it creates a new TCP/IP session, loads that payload in there, and says, hey, send it on its way and gets out to destination B. So what you have is, on the source side, you have a TCP/IP connection to a normal protocol doing all the things that it wants to do, sending information, receiving information. The payload gets pulled out, sent across, no routing information, nothing else about what is the contents of that is sent across, or the source network is sent across. It's pulled back out, put back into its original protocol, and sent on its way. So therefore, the original A and the original B are still talking their two-way communications, two-way protocols, and you've got a one-way transfer in the middle moving data across. There's a couple other things that are happening there. So you've got a protocol break because you're converting what was TCP/IP in this example to ATM, and then back to TCP/IP again on the other side. So you're actually breaking that protocol. The source side has absolutely no idea where it's actually sending the data to on the B side, because there's a configuration table that says, hey, this incoming traffic gets put on this ATM channel, and that's all it knows. My source goes on this channel, and then on the receive side, this incoming channel gets placed onto this outbound TCP/IP session. So he has no idea where the original source was, and the source side has absolutely no idea where the destination is. That can't be changed. So let's say you had some malware that got introduced inside the facility. Somebody walked in with a thumb drive, and innocently or not or whatever, they came in. They needed to put some software on the inside. Unintentionally, some malware gets released inside the plant. Now, a lot of that stuff will phone home and ask, hey, what do you want me to do? What do I do? Across the diode, because there's no routing information, there's no routing across the platform itself, there's no way for that device to ever phone home. First, it would have to spoof itself and pretend to be one of the whitelisted access points or sources of information. It would have to replicate the appropriate protocol that's being used or monitored on that inbound leg. And then, even if it did all that, it would then be sent across, and there was absolutely no way of controlling where it goes on the other side. So basically at that point it dies, because it's no way to reach a designated or intended recipient on the other side, because there's no way to direct where things are going. So you've got is a built-in solution that's breaking the connections, not routing anything, and not allowing anything on the inside to ever communicate to something on the outside unless it's been configured ahead of time. So the source side is configured by one administrator, completely separate from the destination side, configured by another channel, totally isolated, and can't be. But allows that traffic, that payload, to get moved across without any threat vectors in. So it's physically impossible to come in through the receive side and get into the source side. And it's really preventing things on the inside that are bad from getting out of the network and potentially doing some other damage. Okay, so primary use cases, we touched on this a little bit, but you want to push data, don't let people reach into your network. You want to do remote monitoring, so these are the alarms, events, basically any kind of file, email notifications. So we have people with diodes working in data centers, and they just want to get that information out of the data center, that if the drive has failed or some piece of equipment has failed, without a possibility of somebody getting back into that data center. Software updates, we talked about getting those patches in, updates, any other kinds of executables, where you're doing your due diligence on the file itself before it gets transferred in, and then you have the protocol breaks, you have the non-routing capabilities. All those protections are built in, even for your one-way in. And then you've got your standalone two-way connection where you want to maybe do some remote command and control. And we've heard this many times. We'll be out at conferences, et cetera, and folks will say, I get the one way out, I get the one way in, but I've got this one application, or I've got a substation that's out in the middle of nowhere, and I want to roll a truck to get out there. So how can I get in? And so the heavily managed two-way connection is really how that's solved. Okay, so let's go look at some of these use cases. So in this case, I'm in a shipping environment. I've got information on a cargo ship that needs to get sent out. So maybe I've got, obviously I've got drive systems and PLCs controlling steerage and all those kinds of things on the ship. I'm collecting information in a historian. I've got maintenance data. Maybe I just have general databases, manifests or something of what's, my cargo. That information all has to get out to the vendors. The logistics guys are going to back up and load trucks and haul the stuff off and go wherever its ultimate destination is. I got third parties that need to do maintenance on the ship while it's in port, etc. So all good data that needs to get out to third parties for good reasons, but you want to make sure that no one's coming in and accessing any of the information on the ship or the systems on the ship and doing something or planting something that would prevent or maybe influence or affect normal operations of the ship, maybe 2 days, 10 days out of port when they're actually back underway. So there's an obvious use case there. If we look at a land-based solution, really the same kinds of things. Maybe you want to replicate a HMI screen to a third party or a remote remonitoring center. Maybe it needs to be Modbus or OPC kinds of traffic or data. It really doesn't matter because, as we said before, it could be at the transport layer, at TCP/IP or UDP or FTP, or it can be at the application layer where you're sending things across and then you proxy it. So the implementation and the functionality are the same. You just have to be aware of what kind of data and how you need to get it out and what the protocols are. Next use case, this is the one we talked a little bit about moving patches in. So you see here is I've got my trusted vendor out there. So this is maybe an OEM, maybe it's just Microsoft. I got my PCs or my laptops inside the plant or facility that I need to get my latest patch to. You download that patch. Independently, you get a hash from them, certifying or verifying this is an authentic file. You build a manifest that says, these are the files I want to transfer across, and here's the hash code for those particular files. The system will run checks against that. It can run checks against file extensions, file types, do ASCII checks. There's a variety of checks that can be run, and it's really up to the operator to decide what they do and don't need to check on a particular file. Once that file has been verified, that it's allowed to go across, it'll transfer across the diode and then be ready on the inside for whatever it needs to be done. If it doesn't pass the checks, then it's quarantined or automatically deleted. It's really up to the administrator to decide what to do. But in this way, you've got a one-way in only, and you're vetting that file before it ever crosses the threshold into that environment. In the next use case, this is really the two-way connection. So in this scenario, what we actually have is two diodes going one in each direction. The analogy I like to use for that is the security you run into at the airport. So I'm at the airport, I'm checking in, they check my ID, they check my ticket, they scan my bags, they scan me. I come in, I'm now in the terminal, I fly wherever I go, and then when I land, I don't try and go back out that same inbound lane. I go through a different lane that's for passengers arriving. And typically, there's a physical guard sitting there. There's a line on the bottom on the floor. And once you cross that line, you can't go back in. So two one-way paths, completely independent, completely autonomous, know nothing about each other. But as a passenger, I've been able to make a round trip. Basically, is what's happening with this solution. You're allowing a TCP/IP connection to make a round trip. It's being verified. It's being limited. You can only initiate that from the inside out. so the connection would not be able to be initiated from outside the facility. And then only a very specific traffic thread is allowed through, single port, and you're waitlisting and locking down all the potential things that you're connected to. That's really this use case, and that's really in a situation where it's more than just a piece of data or an update that I need to get, i.e. it's not just a file or a piece of data or an update. I actually have to potentially manipulate something on the inside, and that's where this comes into play, where I can make this connection. I've still got my diode. I'm still doing the protocol breaks. I'm still not pushing any routable information across. I'm not exposing any IP address or any of that information. It's different than a firewall, because in a firewall, of course, you're opening up a connection. It's still a routable connection, and whatever traffic goes across it goes across it. But here, we're still doing the protocol breaks. The outside can't see the inside can't see the outside. Nothing routable traverses, and it's just payload moving back and forth. Okay. The other thing we want to keep in mind is, with all the benefits of what you get from a one-way out, a one-way in, and then a lockdown two-way, the defense in depth notion never goes away. Right? You still need to think about your firewalls, using antivirus, role-based access controls, multi-user authentication. None of that goes away. You want to continue because you still have insider threats. You still have some of those two-way connections, etc. You may have connections that you're unaware of, that slipped your purview, got by you when you were doing your audit of all your connectivity. So the other things that are being done don't go away. But what you do now is you've tried to eliminate as much of those threat vectors as possible and reduced your possible methods and access points coming into a network to the greatest extent possible.
Scott, let me jump in there for a sec,
sure.
if you don't mind. We have a question here, and I think it's topical. This is coming from Corey regarding one-way out communication. If a threat actor is dedicated enough to get malicious code inside the ICS, for example, a physical access, wouldn't it also be expected for the threat actor to be able to intercept messages a third-party system is receiving and route communication from there? What are your thoughts about that?
Sure. So I assume Corey's asking in a two-way solution, probably not in a one-way solution. Probably that third scenario. Oh, one-way, is this one-way out? So if it's one-way out, and so let me just describe a little bit more detail about that, about the data diode.
Okay.
So the data diode on the source side has a LED basically that's sending light. The data actually is traversing a fiber optic cable, and on the outside of the receiving, the destination side, there's a photoreceiver that's receiving the light. So you'd have to defeat the physics of that to ever send light in the opposite direction if you're talking one way out. If that's the question, I think that's the answer.
Okay.
Okay, so Dan's here with me, and he's sort of saying maybe it's also from the red side of the diode out to the third party. Now, there's methodologies. We do encryption, so you could potentially encrypt end-to-end, and there's things like that that can also be layered on. Without getting into a ton of detail on exactly all the features of what's capable there, but there is capabilities of doing encryption and other methods to ensure that the data in transit is also protected. So that goes to answering Corey's question also.
Okay, and while we have a little aside here, I'll ask another question here posed by Charles Huffman. He asks, how do you handle RDP sessions to servers in a DMZ?
So we work with quite a few customers that have DMZs existing, and we typically will sit right where the firewalls are today. So if you're protecting a plant and then you transition into a DMZ, and then maybe you come out and you're going to a SOC, or you're maybe just going to your regular IT network, or whatever's on the other side of the DMZ, we would sit at the edge of that DMZ, in much the same way a firewall would sit there. that is typically where the solution sits, is right at that edge of that DMZ.
Okay. And Scott, we have a couple other questions coming in here, but we're nearing the end of your deck, so let's finish that, and then we can open up a full round of Q&A.
Sure, yeah, I just had one. It was really just a summary slide that really talks about mapping your networks, limiting those unnecessary connections, and then doing the conversion to one-way out, one-way in, and then for any remaining two-way connections, locking those down per DHS recommendations, single IP address, single port that's opened, and then heavily managed that one connection. But we can go straight to questions now if we want to.
Okay. I will, let me do a little housekeeping here. I'll let you catch your breath, Scott. That was excellent. I'm going to advance to this slide here. Just a couple items here. On the left side of your screen, you'll see some handouts that are available. There's a white paper, 7 Steps to Defend Industrial Control Systems, that is similar to the presentation that Scott gave this afternoon. There's also a deck of the actual presentation slides that we just saw. You can download those pieces of content there. There's also a PDF with details about the 2018 Smart Industry Conference. It's our 4th annual conference. This is a little plug for the Smart Industry side. It's coming up in September in Chicagoland, and obviously cybersecurity is the main focus of our conference each year. So I invite you to check that out and find the discount in there. We're at the Q&A section right now, so I would like to really open this up to a full discussion. Please do submit questions via the question box there on your screen, and I will process them and I will pose them to Scott. Scott, you ready to field some new questions coming in?
Ready to go.
Okay. This comes from Daniel. He asks, why would someone use a bidirectional data diode solution instead of a firewall?
Sure. So it's some of the things I've laid out before, but instead of opening a port, a pinhole, however you want to characterize it, and allowing a flow back and forth through it, what you've done with a bilateral is now or bidirectional solution is you've limited who can initiate that session, so you can only initiate from the inside, not the outside, right? So you're not allowing people just to say, hey, I want to talk to something on the inside. It's got to be initiated from the outside, so the outside person needs to be the recipient, not the initiator. You're putting in your conversions from your native protocol across the protocol break to the other side. You are hiding the IP information from the inside of the network. So there's a bunch of different things that are going on that are offering much more protection than a firewall. And in fact, if you're familiar with Rapid7, they do penetration testing. They've actually done extensive testing on the product and proven that it is, in fact, more secure than a firewall. So if anybody's interested, we can make the summary of those tests available to folks so they can understand, in depth, what was tested, how it works, and what it prevents.
Okay. Let me take a break here and alert the listeners accessing the webinar on demand in the future. You too can ask questions of Scott via the question box there. We will get those questions provided to him and provide you an answer via email. So please do post questions if you're listening on demand. Scott, a question I had for you. Are most clients aware of the data diode approach when you present that, or is it a new concept that they haven't heard of, that they don't really know much about?
Sure. It really depends. Sometimes we go to conferences and there's people that have heard of it. And what we're seeing really recently is there is definitely a growing awareness that data diodes exist. I mean, they're not new. They've been around for 20-plus years. Initially, used by the government agencies, intel agencies, et cetera, moved into critical infrastructure really in 2008, 2009 with nuclear taking the lead there, early adopters, then into oil and gas, and now you look across many, many industries. But still, easily more than 50% of the people that we run into on a day-to-day basis, that are interested but are cybersecurity focused have never heard of them. So we are still having to educate folks on what they do and how they work, but we are starting to see them. There's a automated car standard now for data diodes and how they might work in autonomous vehicles. So you're seeing a wider breadth of access. And, we get folks coming to the website that are in the, winemaking businesses, in the food and bev businesses, and gun manufacturing, right? So it really covers the gamut in terms of folks that are now starting to look at them and examine them and roll them out. So it's still, there's still a lot of education that's going on, but it's starting to move.
And a question from Kevin, what are the weaknesses of data diodes?
So probably the greatest weakness or the hurdle to get over is folks thinking, okay, this is a niche thing that only works for this specific environment or that kind of thing, and that you have to think about the converting things to one way. So if normally my application is an end-to-end with an acknowledgement rather than an acknowledgement at the transport layer, then that's something people have to think about and say, okay, well, how do I redesign or how do I rethink how I'm getting data out to my third parties? And is there a way I can easily convert something? So that's one of the biggest challenges is just getting people to think in terms of one way versus, your sort of standard two-way. And I think once you start to think that way, say, okay, well, yeah, it's clearly I can push this data, or this is TCP/IP, or there's a protocol acknowledgement, a protocol layer, or application layer acknowledgement. Do I really need that? Is it important? If as long as I know the data is getting across. And there's quite a few, we didn't get into this at all, but on the diode itself, there is an acknowledgement capability. And what we do is we change the onus on the receiving side to be the one to verify that it's received what it should have received. So normally people think Scott's sending data to Chris. Hey, Chris, did you get what I just sent you? And then you would respond and say, yeah, I got what you sent me. Send me some more. Right. What happens in the diode, you can't tell me that you got what I sent you. So instead, what we do is we send markers and checksums and hashes on the data we're sending across, and you look at it and say, okay, yep, I got this. I'm expecting this next, and did you get that next? And now the onus is on the receiving side to say, did I get everything that I was supposed to get, rather than the sender saying, did you get everything I sent you? And so there's a whole algorithm around how that works. Obviously, if you didn't get it, if you notice there's an anomaly, then what you would do is raise an alarm or send an error or something saying, hey, I'm not getting what I expected to get. And this typically doesn't happen. The latency on the platform is in milliseconds, 3 to 4 to 5 kinds of milliseconds. And because we're going such a short distance over a dedicated cable that's not, and I say cable, fiber optic, it's not routing. There's no switching in there. There's no anything that's traversing. It's dedicated point to point. There's no reason if you're operating with within the bandwidth limits of the device that packets or anything would ever get dropped. There's just no reason for it to ever happen. And so we have customers, literally come up to me at a conference. Yeah, we had to change something the other day. We hadn't modified it in 2 years, and I had to go dig around and find the password because we set this thing up and it's just running quietly in the corner, and we never have to touch it. So that's the kind of environment you're working in.
Another question from Charles here, Scott. Where do data diodes fall in the business land? Firewall, DMZ, firewall, control network?
So where do they fall? What?
Where do data diodes fall in the business?
Okay, gotcha. Sorry. So yeah, they would. So it really depends on the configuration and who wants to manage it. We see them typically physically located within, let's say, I'll call it the plant, right? Whatever that is, it's a pump station or whatever it is that you're protecting, with one side facing the inside of the plant and managed typically by someone at the plant that has knowledge of it, and then the other side could be managed by the IT department, whatever network you're connecting to get that data out to the final destination. So sometimes it's the edge of the plant, sometimes it's the edge of a DMZ, sometimes it's on the ingress side of an IT network. So if you want to talk roughly, high-level OT versus IT, it could be at the edge of the OT network, the operations technology network, at the edge of we've seen them at the edge of a SOC, right, Security Operations Center, or a NOC, or someone's doing replication, and so they may want to protect the final destination of a replicated database or a historian or something like that. So there's lots of different it really comes down to how you're going to manage it and who owns one side and the other side. Because again, they're managed completely independently. There's no way to manage both sides of the box. So it comes down to network configuration, but most of the time we see them at the plants.
It sounds like a related question. This comes from Daniel. He asked, do you need one data diode for every external connection?
So the answer is no. So you can have as many, right, so you can have lots of sources of information on the inside. So like we saw in some of those use cases where you could have, PLCs reporting information, I'm getting syslog information, I'm getting historian. All that information can be down funneled through a single diode across, and then on the other side it can go out to one or more destinations, however you want to set up the information to configured. And then there's also fault tolerant and failover scenarios too, where you could have things operating in parallel and one side taking over for the other if there was a failure.
Okay. Let me ask you a fun question here, Scott. What's the most unusual case of a third-party enabled attack that you've worked on? Anything really strange that you've seen that you think back on and saying, wow, that was a really unusual situation?
Well, because of the nature of what we do, we don't usually see attacks coming through. What we do see is customers, and customers are very reluctant for us to talk about who they are and that thing. Unfortunately, I'd love to.
Right.
We have a marquee of really great customers that I'd love to talk about, but they really prefer that we don't. But what you can do is sometimes we'll see articles in the paper will say XYZ facility was attacked, and typically what you see is that attack is against the IT network, right? That's coming in through email, but the generation facility or whatever it is, the actual, where they're actually delivering product, if you will, if that product may be electricity or that product may be, some kind of manufactured goods or whatever it is, the plant that's producing that product was, not attacked. And they say, well, that was limited to just the IT side or just our, email server or whatever. Our plant was never in jeopardy. And so we see a lot of those scenarios where there was an infiltration, hit the IT side, but never was able to get through the OT side, and that's really because you've got basically a diode sitting there in between, preventing anybody from getting in. So those are the kinds of things we see. Okay.
You have a fan here, Scott. Maria asks, what is the next upcoming conference that you are attending at which you could see data diode demo in action?
We're doing stuff all the time. We've got a cybersecurity summit coming up. Actually, we'll be in Rhode Island. I think that's in beginning of July, but yeah, that stuff's all listed on our website. So anybody's interested in where we might be, because we're in a bunch of different verticals. We attend water and wastewater shows. We attend nuclear shows. We attend oil and gas shows. And then on the DOD Intel side, we're going to Air Force bases and Intel shows, et cetera. So because of the nature of how these are used, we end up going to a lot of different places on a regular basis. We probably go to, 60 different conferences, both domestically and internationally every year. So we got a very busy marketing department trying to cover all those shows.
We'll keep an eye out for Maria.
Yeah,
here's a question
exactly.
From Francisco. Where can I find a vendor with this technology using data diodes?
So OWL is a vendor. We do provide that technology, so you can certainly look at our website, and we have a product suite that scales from very low, so 5 megabits, up to multi-gigabits, 10 gigabits, and it really depends on how much data you have. So we see customers that maybe just have a single turbine or something, or a solar facility where they just need to keep an updated, sort of a trickle of data, so to speak, coming out, and they would tend to put a lower end solution in to get that OPC traffic or whatever it is off of that device back. And then we've got full plants running, doing database replication or historian replication and millions of tags, with updates and throwing that across. So you can take a look and you can see that spectrum of solutions available, really looking at what protocols, someone who needs to do support simultaneously, how many flows, and then sort of what that bandwidth requirement. And then the sizing, depending on if you like the 1U kind of form factor, where you've got a 19-inch 1U rack mount solution, or we also have DIN rail solutions, that would mount, with like any other Rockwell or Schneider equipment in that kind of form factor. So a bunch of stuff out there. Very interested to talk to somebody if they're interested in talking to us.
Okay. Look to the future a little bit here, Scott. How do you see attacks changing in the coming 5 years? What's looming on the horizon?
Sure. I think what we're starting to see is people. If you think back to that one of the earlier slides, we talked about the Internet of Things and the industrial Internet of Things, where you've got cameras now and you've got other small devices that need to be protected. So we're seeing, let's say, growth and expectations coming from our customers where they're saying, you know what, I've got this really small endpoint. I don't need a lot of bandwidth, but I want to make sure it's secure. So whether that's some sensor along a pipeline or some camera at a bank or whatever it is, so we're looking at those. We're seeing people very interested in those point solutions as the Internet of Things sort of explodes. The other end of the spectrum is the cloud, right? And everyone's talking about big data and lots of cloud storage and repositories and backups and all that. So the question is how do you populate the cloud, right? How do you get stuff into the cloud without someone coming into my plant? So I'm generating tons of data. Maybe it's not going directly to a third party. Maybe I'm just putting something up in the cloud that someone can access. And maybe those are mobile devices. I mean, that's probably one of the other things we've seen recently was I've got 8,000 wireless users, and they need to run an application to go hit against the database. Well, they can do is they'll hit an application that's outside of that secure database. The diode would do the communication inside to the database, so you got a single point of connection into that data source, bringing that data back out, and then distributing it through the application. So I think as the cloud gets, it's already prevalent, right? I mean, it's not like it's around the horizon. It's really there today, and it's really talking about bigger, larger amounts of data and how do I populate the cloud and how do I populate those repositories that are being used and shared inside the cloud and keeping my source of my information secure. You think about the Equifax breach, right? Well, if they had segmented their network properly, right? Me as a car dealership, I need to verify that, hey, Chris, does Chris have good credit? Should I loan him, make him this loan for this car? I should be able to access your information to say yes or no, but I shouldn't be able to look at all your details and know your credit history and all those other things that they use to make a decision, right? That should all been protected, segmented better, hidden behind, a diode potentially, and said no one needs to access this. Only our analysts on the inside will make a determination as to what Chris's credit rating is, but on the outside we'll make available in the cloud, let's say, an application where I can put your social security number, your name, blah, 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 and I come back with a credit score so that I can, as a dealership, I can do my job without exposing that sort of the information of thousands or millions of people. So those are the things people have to think about moving forward.
Sure. We're nearing the end of our time window here. If there's any last-minute questions, please do submit them. Gramesh asked a question about, this isn't for you, Scott, this is kind of housekeeping. Will there be a recording of this WebEx available to view later? Yes, of course. The webinars are always on demand. You could log in exactly as you logged in for this live webcast to access it, and you should be receiving the communication with the URL once that is available on demand. And again, those listening on demand can submit questions via the question box, and those will be replied to in due time. We'll give it about 30 more seconds. Again, there's a handouts section on the left side of your screen with collateral from today's event and a offer for the upcoming Smart Industry Conference in September. When we leave the session here, you'll be prompted to complete a quick survey. We ask that you take that to enable us to make future webinars even better. And unless I see anything come into the question box in the next few seconds, I'm going to say to you, Scott, thank you for sharing your expertise today. That was great.
Thank you for the opportunity. We appreciate the time and everybody who was able to attend today.
Yes, and thank you to everyone who joined us. Have a wonderful day.